Hi everyone, this is Sandeep. So now I'm here to explain you about the big data project that we have been working on. Me, Arshad, and Mudassir. So the aim of our project is to use historical road accident data from London API provided by the TFL Accident Stats API to predict the severity of accidents. So now I'll explain the data source that we have used for our project, which is the TFL Accident Stats API. So this API is an open data platform provided by Transport for London, which will allow us to integrate real-time and historical transport data into applications and any other tools. So the TFL API, so this for our project will be used. So firstly, for to access this particular API, we need to create an account. We have to sign up an account, and after signing up for an account on this website, we'll be giving an API key, which we can use it in our code to access the endpoints that are available on this website. So the TFL API hosts many endpoints such as accident stats, air quality, bike points, and many other endpoints which we can get data from. And for our particular project, we'll be using accident stats API. So in this from this particular API, will be so this particular API is a simple REST API. So we can query this particular API using simple HTTP requests. So when we make a GET request to this particular endpoint, the server responds with a JSON format, with a JSON object, which gives all the information that is shown on the screen. So firstly, it gives us the ID of the accident, and we have the location of each accident given as latitude and longitude coordinates, and there is the date and date of the accident, which allows us to analyze the patterns by day, week, or year. Third, the data set provides details on the vehicles involved, such as cars, bicycles, buses, or motorcycles. And next, it also includes information about causalities, such as number of people injured or killed, and severity of causalities, like whether it is slight, serious, or fatal. So finally, we get contributing factors like vehicles also, and so these are JSON object that we get from the particular API. And after getting the data, we'll be using ETL logic to extract, transform, and load it into a place where we can use it for downstream use cases like our to build our machine learning project at the end. So Navan, from here on, Arshad will be explaining you the ETL process. So here
Thank
for you,
you.
Arshad.
Thank you, Sandeep, for the detailed introduction of our project. Now, hi guys. My name is Arshad. I'm going to explain you about our uh, data ingestion and data processing aspect of this project. We have hosted this project on Google Cloud Platform. So I will be talking about few components of Google Cloud Platform that we are using for this project. Firstly, let's go to Dataproc. In Google Cloud Platform, we are using Dataproc. This is a fully managed service for Apache Spark and Apache Hadoop jobs and big data engineering framework. So I have created a data proc cluster called TFL data pipeline. Under this cluster, we have submitted the jobs for the PySpark with the PySpark code. And then for the storage perspective, we are using Google Cloud Storage. Under the Google Cloud Storage, I have created a bucket called TFL data bucket for this project. Under this bucket, I have created folders called raw, processed, and ML. So in under the raw folder, we have the raw dataset that we have downloaded using API. This is our road traffic incidents that happened in 2018. This dataset contains data points of 2018. So I'll show you how our extract code looks like. This is what our simple extraction in PySpark code. First, we have to create a Spark session to make Spark run, and then this is a API URL, and then this is my API key that I have got after registering, and then I'm requesting it to the server using this UPI and my app key, and then once we get a response, I'm storing it in a data variable, and then it will go on to saving in a raw folder in our Google Cloud Storage bucket. This is a simple extraction file. Once we have extracted a raw data, then we will do a transformation on that. This is our transformation.python file. Again, we are creating a Spark session, and then this is we are specifying an input path. Under this Google Cloud Storage bucket, we have a JSON file input file, and then we are reading it into a Spark data frame, and then we are exploring casualties and vehicles arrays because these are in nested loops in JSON format. So we are converting back, and then we are selecting relevant fields from this data frame such as ID, latitude, and we are giving an alias name uh, to have a meaningful name, and then longitude. Severity goes as accident severity and everything. The age, class, severity, mode falls under casualty. We are giving as a casualty age, class, severity, and so on. And then again, we are saving this cleaned and transformed data to a Google storage a bucket called accident stats 2018 cleaned under processed uh, folder. This is the end of this transformation part. So this concludes my data ingestion from API to Google Cloud Storage, and then using Apache Spark. The further aspect of this project, that is loading data into Google BigQuery and doing a machine learning model on this project, will be explained by Mudassir. Mudassir, over to you.
Thank you, Arshad. Right, so now that we have the process data, there's two ways that we can go. We can load the data into BigQuery and do some SQL analytics on it, and also visualize it in using Looker Studio, or we can create an ML model. So we have done both. Obviously, first let's delve into the BigQuery in the Google Cloud. So we have loaded the data into BigQuery here. You can see the road traffic data and all the transformed columns that we have transformed using our transformation code. So this verifies that the data has been loaded successfully and correctly. And here we have run a select query just to verify again and confirm that all the data has been loaded correctly. Now we also made a visualization because that's also a capability that we can use from GCP. Using Looker Studio, we have here constructed some metrics on the accident data that can give you some insights on the data visually. But our main focus again is the machine learning model. So going back to the machine learning model here using PySpark under the Dataproc capability in GCP, we're leveraging the Spark's distributed computing capabilities here. And the code starts by creating a Spark session and loading our accident data from the Google Cloud Storage itself that we saved before. And we then enhance our data set by extracting some temporal features like year, month, day of the week, and hour. We are also handling the categorical data like borrow names and implementing some pre-processing steps so that the frequently occurring borrows and groups, less common ones, are classified as other, which reduces the noise. Um, the heart of our pipeline here is the random forest classifier, which will be predicting the accident severity. And the features that we are using for this, again, are the location coordinates, the vehicle types, and the borrows names as well. Once we run the model after the splitting of the data, we actually get a very impressive accuracy of 85% on the test data. We can show you the results here. you can see the test accuracy of 0.85, which is really good. That means our model is classifying the data really well. We have used the evaluator classification evaluator libraries to get that accuracy, which is built in the PySpark ML. So from this implementation, the traffic safety analysts can make highly accurate and data-driven decisions to improve the road safety based on predicted accident severity patterns. Plus, with this infrastructure, we're using the GCP and we're using the distributed computing capability of PySpark as well. Thank you.